Welcome to AcadUCATION. Hello everyone. I'm sure each and every one of us remember those calendars which used to come printed at our last page of the notebook, 100-year calendars, where we could just enter some numbers and we were able to find the exact day for any date, right? So let us now understand how can we do this with some basic concepts. This is our topic, calendar test. Do you remember Bloody Sunday from Russian Revolution? It occurred on 9 January 1905. It is known as Bloody Sunday, right? So it should have occurred on Sunday. But if we Google it now, 9 January 1905 was Monday. How is it possible? Or why is it called Bloody Sunday then? So that is because when that event occurred, they were using Julian calendar. So according to that, it was Sunday. While what we are using right now or at present is Gregorian calendar. So according to that, it is Monday. So there are many type of calendar. We have Gregorian calendar, we have Hindu calendar, astronomical calendar, and many more. But the most widely used calendar is our Gregorian calendar, and this is this calendar only we are going to discuss in our further discussions. Now, Gregorian calendar year has two type of years. One is leap year, and the other one is ordinary year. Now, what are these leap years and ordinary years? Let's see them. Now, leap year is the year that has 366 days instead of 365. Our ordinary year has 365 days, while a leap year has 366 days. Why? Because it has 29 days in February instead of 28. Whenever a given year is divisible by 4, we call it as a leap year. But if that year is a century year, such as 1900 or 1800 or 2000 or 21st century, that is 2100, so that should be divisible by 400. Then only it will be counted as a leap year. Now let us see why we say that 1700 or 1800 or 1900 is not a leap year. While for a non-century year, we say that if it is a multiple of 4, then it will be a leap year. Why is it so? Let us have a look. Now the earth revolves around the sun in 365.2425 days. This is exact up to 4 place of decimal. So this much time the earth takes to make one revolution around the sun, that is in a year. Now in 1 year we have exact number of days or whole number of days. We can't have this 0.2425 number of days, right? We have either 365 days or 366 days. So to solve that problem, what we did was we took 365 at one place, 0.2425 at another place. So we divided this 0.2425 in two parts. Now what were those parts? 0.25 minus 0.0075. So if 0.25 we subtract 0.0075, what will we get? We'll get 0.2425. So now what we are doing is we are adding this 0.25 for 4 years. In 4 years we'll have 4 times 0.25. So in 4 years it will form one extra day, right? And when it forms one extra day, we can say that every 4th year there is one extra day in the year. So for 3 years we get 365, and each year we have 0.25, 0.25 and 0.25. So 0.75 and 0.25 of the 4th year. So we have every 4 year we have one extra day. So that extra day forms the leap year. But we are adding extra 0.0075, right? Because what we were required to add was 0.2425 and we are adding 0.25. So now if we have to subtract this quantity, when we multiply 0.0075 by 400, we get 3. So can I say that every 400 years we get 3 days extra because we are adding this 0.0075 every year. So in every 400 years we subtract this 0.0075 so that at the end we are adding 0.2425. So now when we subtract this 0.0075, so 3 days have to be subtracted in 400 years. So that we do by subtracting from our century years. That is from 100th year, from 200th year, and from 300th year. So we subtract 1 day from each of these. Right? So when we subtract these 3 years from 100, like 1700, 1800 and 1900, so what we'll get is the concept of leap year, that every 4 years there is a leap year, but for century years we take it every 400 years, right? So 2000 remains a leap year because we have subtracted 1 from each of 1700, 1800 and 1900, and it has not been subtracted from 2000. So this is a basic algorithm on how to check if a year is a leap year. So first of all, we'll check if it is a century year or a non-century year. Now if it is a century year, then we'll divide it by 400. If it is divisible, it is a leap year. If not, it is an ordinary year. Similarly, if it is a non-century year, we will divide it by 4. If it is divisible, it is a leap year, otherwise a non-leap year. So this is how we'll check if a year is a leap year or not. Now to solve any question on calendar test, we will be required to find odd days. What this odd days means? Whenever we divide any number by 7, we get our odd days. Odd days can range from 0 to 6 because if you divide anything by 7, your remainders can be from 0 to 6. It can't be more than 7 or equal to 7. Now if you get number of odd days as 0, then you have a Sunday, 1 you have Monday, 6 you have Saturday. So that is why we take out our odd days, because our odd days gives us what day it is. Okay. Now let us find out how many odd days are there in any ordinary year. So any ordinary year consists of 365 days, and if you divide 365 by 7, what you'll get? 7 5s are 35. We get one remainder, taking 5 here, we get 7 2s are 14, and what we get as 1. So now 52 represents the number of weeks, while this 1 represents what? Odd days. Clear? So whenever we divide 365 by 7, we get 1 as remainder, and this 1 is what? Our odd days. So any ordinary year leaves 1 as odd day. Now what this 1 means? That any ordinary year has 52 complete weeks and 1 extra day. And what this 1 extra day will do, let us see in our another line. This means that ordinary year ends on the same day as on the day it started. That means if 2005 started on Monday, that is 1st January 2005 was a Monday, this means 31st January 2005 was also a Monday. Like this, we have our January 1st, January 2nd, January 3rd and so on. So these will follow. First week is finished, this is our second week and so on. So 52nd week will finish here, and we have 1 extra day, that is Monday. So this will be the same day as it was when our week started. So if our week would have started on Friday, the last day would have been Friday, right? So this is 52 weeks and this is 1 extra day. So odd days in any ordinary year is equals to 1. Similarly, let us see how many odd days are there in a leap year. So what we'll do is we'll divide 366 by 7 because we have 366 days in a leap year. We will get 2 as remainder. This means we have 52 weeks and 2 extra days. What these extra days will do? As we saw previously, if our year started on Monday, in ordinary year case, our year was ending on Monday itself. But now we have 1 extra day, we have 2 days. So our year will end on Tuesday. Similarly, for example, if in a leap year, like if 1st January 2000 was Wednesday, then 31st January 2000 would have been Thursday. So it will end in the next day from which it started. So number of odd days given by leap year is 2. This odd days we have to remember because whenever we'll be going to find any day given the date, we'll require this odd days. So just remember, any ordinary year gives us 1 odd day, while a leap year gives us 2 odd days. How do we take out odd day? By dividing any number by 7. Now as we discussed in the beginning, what we'll be doing is we'll find the day on any given date. Like what was the day on 15th August 1947, right? The day we got independence. So 15th August 1947, how we'll find the day? We'll first take out the odd days up to 47 years. Similarly, odd days up to 19 centuries, number of odd days up to August, and number of odd days up to 15 days. So 47 years, 46 years have passed away. So we'll take the number of odd days till 46th year, at the end of 46th year. Similarly, we have to find out the number of odd days in 19th century, because 19th century was over, right? It is the 20th century. 1947 means 20th century. 1900 years are over already. So we'll take our odd days till 19th century. Similarly, we'll use the code for August. So how do we take out these codes? Let's have a look at that. First of all, we'll find out the odd days in first 100 years. So our calendar started on 1st January 0001, and that was given the day as Monday because it was our first day. So number of odd days was 1, and we saw earlier that 1 odd day means Monday. 0 was Sunday, 1 was Monday, and 6 was Saturday. So now for 100 years, we'll find out number of leap years. Now number of leap years would be 25 or 24. It would be 24 because when we divide 100 by 4, we get 25. So our leap years would have been 25, but it includes the 100th year, which we know because being a century year and not being divisible by 400 is not a leap year. So because 100th year is not a leap year, we'll subtract 1 from 25. So number of leap years in first 100 years, it is 24. So our non-leap years or ordinary years would be 76. Now we know that in 100 years, what would be the number of odd days? It would be number of odd day in non-leap years plus number of odd days in leap years. So odd days in leap years plus odd days in ordinary year. How many leap years did we had there? 24. So 24 multiplied by number of odd day given by 1 leap year, that is 2. And 76 was ordinary year, and 1 was number of odd days given by an ordinary year. So 24 into 2, 2 was the number of odd days given by leap year, 1 is the number of odd days given by ordinary year, 24 is number of leap years, 76 is number of ordinary years. So when we add these, we get 124. Now I told you earlier that odd days cannot be more than 6, because whenever we are finding the remainder, remainder is always less than or equal to the divisor. If you are dividing something by 7, your remainder must be less than 7. So what we'll do is we'll divide 124 by 7 and find the remainder again. So when we find the remainder of 124 by 7, we get 5. Now similarly, number of odd days that we'll get in first 200 years. So again, we'll take out the number of leap years in first 200 years. It should have been 50, but 100th and 200th year is included. So it would be 48 leap years. Now 48 leap years and 152 non-leap years or ordinary years. So if we add these, that is the number of odd days in leap year, it would be 48 leap years multiplied by 2, number of odd days given by 1 leap year. Similarly, number of odd days in ordinary year, 152 ordinary years multiplied by 1, that is the number of odd days in ordinary year. When we add them, we get 248. Divide 248 by 7, you will get the remainder as 3. So these you have to remember, right? That first 100 years, number of odd days that we got was 5. First 200 years, we got as 3. Then you will take out in first 300, then in first 400. And this cycle will repeat itself. That we'll see later on. So this is what I was talking about, that in first 100 years you are getting as 5, then you will get as 3, right? We got number of odd days in first 200 years as 3. Then if you calculate for 300 years in the similar way, you will get it as 1, and in 400 years you will get it as 0. If you will then calculate in 500 years, you will again get 5, and this table will get repeated: 5310, 5310, 5310. So in 1700 you will get 5, because it is the next year to 1600. 1600 is a multiple of 400, and every year that is a multiple of 400 will have odd days as 0. So 1700 would be 5, 1800 3, then 1 and then 0. So these are the century codes that we are going to use. If I ask you what would be the century code for 2100, so now this century comes just after 2000. 2000 has 0, so it would have 5 odd days. Okay. Now let us see the odd days given by months. That we'll name as month codes. So we'll be using directly the month codes in place of number of odd days given by months. Now if you talk about January, it has 31 days. If you divide it by 7, you'll get the remainder as 3. For February it will be 0 because February has 28 days in case of an ordinary year. So when you divide 28 by 7, you will get the remainder as 0. Similarly, for all these months, you can calculate the number of odd days. Now, while calculating any day for a given date, like for example, we are calculating it for 15/8/1947, right? So here you had to calculate the number of odd days till August. So that means summation of all of them till August. So there are two methods to find the month code for this. Either you add all of them, that is because July is over, so you calculate till July. Till here you will be adding, and that would be your answer, which should come out as 2. See, we'll add it. 3 plus 3 is 6, plus 2, 8, plus 3, 11, 13 and 3, 16. And when you divide 16 by 14, you will get your remainder as 2. Another method is, we have just written out all the odd days in the same manner we have added, like for January. So before January there were 0 odd days. After January, before February, there are 3. Then for March it would be 3 plus 0, again 3. For April it would be 3 plus 0 plus 3, 6. For May it would be 3 plus 0 plus 3 plus 2, right? For May it would be summation of all these. So 3 plus 3, 6 plus 2, 8. 8 means again 1. Because whenever you are going to divide 8 by 7, you will get the remainder as 1. So you can remember this table and directly use the codes. You would have understood, right? How do we calculate these codes? We are just adding these numbers. So what you have to remember is 033, 614, 625 and 035. The first 3 and last 3 start from 0 and they are close to squares of 6. Second and third start from 6 and they are close to square of 25. So the 033, 614, 625, 035. And see the sum of all these, it comes out to be 1, which is the number of odd days that we got in our non-leap year. So this is how we have calculated these month codes that you will have to remember. You just remember the ordinary year codes, and for leap year you add 1 to that code, because after February only 1 would be added, right? February has 29 days, so 1 day extra would be added in February. So for January and February the code remains same, and after that 1 is added to each code. So let us now calculate the day on 15th August 1947. So first of all you have to find the century code. So centuries completed are 1900. We know that for 1900 we have number of odd days as 1. The CC is century code, right? Then years completed. Now century has been completed. Let's come to a smaller part of that, years. How many years have been completed till now? 46. Just remember this, do not use 47 here, you'll have to use 46. You'll have to subtract 1 every time whenever you are solving it. So just don't forget to subtract 1, okay? So now number of leap years we have to calculate in 46 years, because we have to calculate the number of odd days. And odd days can be calculated only based on the number of leap years and ordinary years. So number of leap years are 11. We divide 46 by 4. Our quotient is 11, so number of leap years is 11. Remaining years are ordinary years, so 35 ordinary years. Then how to calculate the odd days? We'll add the odd days by leap year plus odd days by ordinary year. So from leap years we had 11 into 2, because 11 leap years are there, multiplied by 2 odd days. Each leap year gives us 2 odd days. And for ordinary year we have 35 into 1, 35 number of ordinary years and 1 odd day each. So this comes out to be 57. When you divide 57 by 7, you get as remainder as 1. Now, year is over. 1947, number of odd days we have calculated. So you'll have to add this. One you will have to add and this one you'll have to add. Because these are century codes and year codes. Now we should go to month code. August. What is the month code for August? It is 2. Right? 625. So that 2. 033 614 625. And after that day code. So day code is directly 15 divided by 7. You will calculate the remainder when we divide the date by 7. So remainder comes out to be 1. Adding all these 4 codes, what do we get? 1 for century code, 1 for year code, 2 for month code and 1 for day code. Right? 1 century, 1 year, 2 for month and 1 for day. All these add up to 5. Hence that day was Friday. Try this another question if you are able to calculate what day it was. Do it for 1 minute and then we'll see. So first of all, we'll be calculating the number of centuries. So 2000 year is over, 20 centuries have passed. So 0 odd days for 2000. Next is 24 years. So just break it in leap years. That is 5. Right? 24 years. So we'll be taking 23. 23 years have passed away. So 23 divided by 4 is 5. Remaining 18 years are ordinary years. Then add up the odd days given by these leap year and ordinary year. How? By multiplying this by 2 and multiplying this by 1 and adding. So we do this, we get 28. Right? We have calculated the odd days. 5 into 2 plus 18 into 1. Now we have our year code, we have our century code. Now we need our month code. So February was 3, right? So month code for February is 3. Then for day code it would be 29 divided by 7. So 29 divided by 7 you get the remainder as 1. Adding 3 plus 1 plus 0 plus 0. You get 4. And if it is 4 it would be Thursday. How are we getting that 4 is Thursday? Because we saw initially that 0 means Sunday, 1 means Monday, 2 means Tuesday and so on till 6. Right? 6 was Saturday. Okay. Just try one more question on that. So what was the day on 18th June 1857? What was happening during this time? The revolt of 1857, right? It was during June and July. Just calculate the day. So again 18 centuries have passed, so code for 1800 would be 3. 56 years have passed, so if you divide 56 by 56 by 4 you will get 14. 14 into 2 is 28. Remaining is 42 years. So 28 plus 42 is 70. So year code is 0. Code for June. What would be the code for June? This is a non-leap year. So code for June would be, what would be the code? 4, right? 614. And for 18, what you will have? 18 divided by 7. So we have calculated our odd days for century, that is 3. We have calculated our odd days for year. So 14 leap years, 42 ordinary years, 14 into 2 because leap year gives 2 odd days. So 28 from here and 42. So we get 70 odd days. So 0 code. Then we have month code as 4 and we get our day code also as 4. Adding all these, what we get? 11. Now again, because 11 is more than 7, we'll find the remainder. So remainder is 4 and hence that day was Thursday. So if you have ample amount of practice, and by ample amount what I mean is around 10 to 12 questions, you'll just need to calculate these 4 things. And these 4 things does not require more than 20 seconds, 5 seconds each if you perfectly know them. So within 20 seconds you can give out the answer. What if our calendars were made of gold? Obviously they would have been really costly, and if they would have been costly, so we would have probably saved them for future use, right? Like for this year's calendar I would be using in future after 4 to 5 years whenever same dates would occur on the same day. So this is the same calendar concepts. Like questions are asked in this as calendar for 1905 can be used in which year, and they will give you 4 options or 5 options. So 2 years will follow the same calendar if, now obviously if 2 years are following the same calendar, so they have to be of the same type. It is either a leap year or leap year or ordinary and leap year, right? Nobody can say that one of the calendars you take as leap years and other one as ordinary, and then they will follow, because in February there would be some difference. And second is on 1st January each year should have the same value of odd day, because if 1st January is same, then the whole calendar would be same. So these are the two things that you have to check whenever solving this type of question. You first check that the 2 years should be of same type, leap year or ordinary year, and then what you will do is 1st January of that year, you just check the odd number of days, odd days. How to calculate the odd days of 1st January? It's very easy. Just calculate the century code, just calculate the year code. That's it, and add 1 to it because of 1st January. Because code for January is 0, number of days is 1. So you just need to calculate the century year, which is direct. For year code, you will have to find out the number of odd days by using leap year and ordinary year, right? Is it so? Obviously, right? If you have 1st January 2015, so you will have to find out the number of ordinary years and leap years for this. So you will be using 14. Using 14, you will find out number of leap years, number of ordinary years. Using that, you will calculate the year code. So year code plus century code plus 1, that is your answer. This should be same for both the calendars. Obviously in odd days, right? Because 15 and 22, these are the same things, right? Monday. So you will have to find the remainder and then compare. So there's one more thing by which you can tell if the same calendar will follow. If two ordinary years have a difference of 11 years, then they are sure to follow the same calendar. Okay, for example, if 2007 and if you take another calendar of 2018, so first of all, obviously they will have to be ordinary, and difference is 11 years, so they would follow the same calendar. You can check it on Google, or if you have the calendar with you, you can check that. I hope you won't be having the calendar of 2018, but still, right? So if you have a difference of 11, then directly you can say that they will follow. I'm not saying that other years do not follow. I'm just saying that if the difference is 11, they will follow. There might be other years which also follow this same calendar, but this 11 years difference will surely follow. You don't have to check them. Similarly, if the difference is a multiple of 28, for example, if they have a difference of 56 years, 28 years, or another multiple of 28, so they will also follow the same calendar. Now here you can have anyone, ordinary as well as leap. In the first one, we could not have a leap year combination because difference of 11 is not possible in case of leap year. Right? 2 leap years will have an even number of difference. So that is why. So you can directly say if the difference is 28 or a multiple of 28, they will surely follow. And if an ordinary year has a difference of 11, they will also follow. Thank you. We would be uploading more lectures on calendar test. That would be basically for practice. So stay updated. And if you have any queries, any doubts related to any topic, you could just mail us at acaducation@gmail.com. We will reply to you ASAP. If you have any questions that you are not getting from any book or any content, you can just take a pic of that and mail it to us. We will upload a video solution to it. So stay updated. Best of luck.